Well, we're going to talk about sequences and series for a couple of weeks right now. We're going to kind of just start off with a little bit of information and just kind of some thinking about it. So the definition of a sequence is an infinite sequence is a function whose domain is the set of positive integers, and the function values a sub 1, a sub 2, a sub 3, etc. are terms of the sequence. Okay. If the domain consists of the first n positive integers only, the sequence is a finite sequence. Okay. So when we talk about write the first 5 terms of each sequence, that would be a finite. Okay, and we almost always start where the term is a sub 1. Occasionally we'll start with an a sub naught, but usually it's a sub 1. So when you were asked to write the first 5 terms, so a sub 1, so just 2 times 1 plus 1. A sub 2 would be 2 times 2 plus 1, just plugging in whatever term number it is in for the n. And then a sub 5. So we would have 3, 5, 7, 9, and 11. So those would be our first 5 terms. Okay. I want to do one with you that has like a negative 1 to the nth power, so you can see what that looks like, and then I'm going to have you do those two while I pause this. Okay, 2 minus negative 1 to the first power, 2 minus negative 1 to the second power, okay, so if it's to the first power, then that's going to stay negative 1. So 2 minus negative 1 would be 3. Negative 1 squared is 1, so 2 minus 1 is 1. And this one actually just kind of goes back and forth. Negative 1 cubed is going to make that negative, so 2 minus negative 1. So the first 5 terms here. So I'm going to pause, and I want you to do 3 and 4 so that you can see what that looks like. So take a moment. Don't just watch me do it. Take a moment. Okay, so here I did this one and I worked it all out, and these are my 5 terms. Okay, and then over here, these are the 5 terms you should have. Okay. One of the things we'll ask you to do is to write formulas from a sequence to try to figure out what the formulas are. We tell you to look for patterns for n squared and n cubed. And one of the things that's kind of helpful just to remind you is, just so if you're at 2 to the nth power, so you might recognize some of the numbers, remember that would be 2, 4, 8, 16, etc. And then sometimes it's nice to remind you about 3 to the n. So that would be 3, 9, 27, 81. Okay. One of the things you can do to try to help you excuse me, figure out a pattern is go ahead and see if you can get yourself to a common difference. So 3 to 10 is 7, 10 to 29 is 19, 29 to 66 is 37, and 66 to 127 is 61. Okay, they don't match, so let's try it again. We get 12, 7 to 19 is 12, 19 to 37 is 18, okay, 37 to 61 is 24. These don't match, so we get to 6 and 6. So here's my first difference, here's my second difference, and then here's my third, and that's where it matched. So we're going to try an n cubed. Okay, so my formula is going to be a sub n. Now I'm going to say n cubed. I'm going to start there. So my first term is 1, would be a sub 1, but when I do 1 cubed, I'm not getting 3. So I'm like, okay, what could I do? 1 cubed is 1. Okay, let's try to add a 2 and see if that works, because 1 cubed plus 2 is 3. So let's see if that works. A sub 2, 2 cubed is 8 plus 2 gives me 10. And it looks like that's going to be my formula right here. Okay. Now, when you have both of these here have alternating positives and negatives, so you're going to have to deal with that. So I will tell you one of the things to do is to remind yourself, if you need -1 to the nth power, okay, that would be if your first term is negative. And then if you need your first term to be positive, n plus 1, that would be my first term is positive. Okay. Because -1 to the first power is going to be negative, but -1 to the 1 plus 2, that would give me a positive first term. Okay, so when you go to do your differences, just ignore the positive and negatives. Just go from 2 to 5 is 3. From 5 to 10 is 5. From 10 to 17 is 7. Okay. Okay, so we had a first and we had a second. So we're going to try to make this formula n squared. Okay, so n squared is, if I do a sub 1, I'm sorry, a sub 1, that would be 1 squared, which is 1. That's not 1. It's 2, so let's see if I add 1, that'd be the obvious thing to do. A sub 2 would be 2 squared plus 1, which gives me a 5. Okay, so it looks like it's going to be n squared plus 1. Okay, I need to start out with a positive and switch to a negative, so then that's going to lead me to believe -1 to the n plus 1. Okay, take a minute and see what you can do with number 7. Okay, and here is what I have right here. Okay, let's turn the page to page 4 and let's talk about some sigma notation. Okay. Okay, when we talk about a series, okay, we are talking about the sum of the first terms. Okay, that's what it's the difference between a sequence and a series. So an infinite series is the sum of the first n terms. And if you do n terms, it's finite. If you do infinite, where you just never end, that's an infinite series. Okay. We are going to spend some time using what's called sigma notation, okay, or summation notation. Okay. And this is really just telling you that you're going to add your terms up. I is the index of summation, or whatever variable. I gets used a lot, x, n. Okay. This is our lower limit, and this is our upper limit. Okay. So this one's fairly easy to do by hand. It says to write the terms from 1 to 4. Okay, so that would be 4 times 1 plus 1. That would be our first term. Okay, plus, so this is just very similar to what we were doing earlier, just kind of a different notation. It's telling us in a different way what we want to do. Okay, and we're only going to 4, so okay, so my terms would be 5, 9, 13, and 17. Okay, and now that's pretty straightforward to add up. We can just say equals 44. Okay. When you come over here and you substitute, this is also fairly simple to do in your without a calculator. Okay. But when we put in our terms, so 2 plus 2 cubed, okay, that's going to give me 10, plus 2 plus 3 cubed, plus 2 plus 4 cubed, and okay, so I get 10 plus 29 plus 66 plus 127. Okay, now add that up also, but you can also use your calculator. Okay, and you would do, tells you right here what to do, alpha window 2, I guess I could turn my calculator on, that would be really helpful. Clear that. Then I'm doing alpha window. See, it gives me all those things, it gives me a summation too. Okay, and then it tells me what I'm going to do. So we'll do the easy one. Let's do number 4 over here. So if I get this, you can see it better. So x, whoops, lost it, need to move it over here. Then 1 to 4, and then 4x plus 1. Hit enter, and hopefully we get 44. Okay. Sometimes with these shorter ones, it's actually easier just to do the calculation without going to your summation. Okay. There are some properties, you know, you can do if you're just summing a constant. It's just going to be Cn. You can pull your, if you've got a constant times a term, you can pull your constant out front. You can separate those, whether you're adding or subtracting. Okay. Now, here's a question. It says, write the terms of the series and evaluate. So 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. So we add those up and we get 50. Now over here, you got to be careful with what the question is asking you. The terms are 2 plus 4 plus 6 plus 8 plus 10, because that's what you get when you plug those in right there. Okay, but the total is 4 times that, so when you do that you should get 120. It's 4 times all those terms. Okay, same thing here. Actually, not same thing here, just plugging those in. And if I have an infinite amount, I apologize, a finite amount, I'm just probably plugging that in my calculator and adding them up. I'm probably not using the summation, but you're certainly welcome to use the summation. Sometimes you're going to be asked to write an equation, a sigma formula. So when we get our sigma notation right here, so we know it's going to be x equals, we want to go from the first term. Okay, and we're going to figure out the pattern right here. So I'm hoping you guys are noticing 1, 4, 9, 16, that those are squares, that we can just write this 3 over x squared. Okay, and then we'll go from 1, and hopefully you remember. Okay, now this may be one you want to take a minute and put your summation notation in. Okay, so I'm going to do alpha window, and I'm going to do number 2 because that gives me sigma notation. I'm going to do x 1 up to 11, and then I'm going to put in alpha y equals, so I can get a fraction, 3 over x, oops, let me move, that's a square, let me take this back and put my x right there. Okay, looks like I'm going to hit enter. I get 4.674, so we're going to hit math, enter, enter, and see what that fraction looks like. Okay, it doesn't happen to give us a fraction, so we are going to take this to 4.674, 3 decimal places. Okay, always check and make sure if it gives you a fraction. Okay, I'm going to stop right here for just a minute, and then I'll be right back.